unmute yourselves. Uh, this is the one that doesn't mute by default. All right, here we are. What's the date today? The 22nd. Time is flying by. This week's been a bit of a, I don't know, a kind of housekeeping week. I've put out a lot of new code over the last couple weeks, and Peter, thanks for helping find some bugs in Agentic Flow, some corner cases on because there's so many different places that I'm compiling for, like Intel or ARM or Mac or Windows, Linux, and then I need to compile for the sort of chip environment, everything from an ESP32 on up. So there's a lot of moving parts here, but I'm fixing them to be honest, there was no major bugs that were like showstoppers. So that's a good thing, I guess. It's definitely been popular. I had my first 100,000 plus download week for Claude Flow, so that's pretty cool, I guess.
It's
Not to
huge.
brag, yeah, but I am bragging. Whatever. And yeah, hey Rob, how's it going?
Great, great, my man. Yeah, there's been, I think you've had, is it two or three fascinating new releases this week? The model, which is really neat to see that you use the recursive language model in that, and then the browser. I haven't even had a chance to try the browser out.
Yeah, well, the browser came out of, I actually do have a day job, and it usually involves fixing the bugs that I made the day before. So I needed a way to do end-to-end testing, like the testing you do right before you're about to launch, or you're now live and you don't want to break what you've already put out there. So, kind of end-to-end test that happens. I kind of double, triple check that happens when you go from like development to production. And it's great for
Hmm.
that. It logs in, it does the various parts of the app. So basically, you can set it up to essentially try and use every single part of your application, and it just kind of mimics that, and it works great. And you can do a swarm, right? So you can you can simulate what 100 users visiting the site all at once might look like, or a
Oh,
thousand.
spectacular.
Yeah, it's cool.
Okay, that's my
Uh,
afternoon.
Yeah, it's useful. Like, because the number one thing people are asking me lately is like, how do I go from like vibe coding or developing something to production?
Mhm.
And it's tricky. No matter what, it's still that's the part that really does still require some human involvement. Now, some people will say CI/CD, and it's been well known, but when you're moving as fast as we are, you crank out, random Tuesday, 30,000 lines of code, and then you're like, is it secure? Does it work? So a lot of that is still just mixed. I have to take a look and just make sure it does actually do everything that it's telling me it's.
Presumably you can use this instead of Playwright then, yeah?
It's all Playwright. Yep, it's all built in Playwright. It's built on the
Oh,
Vercel agent browser agent toolkit. But yeah, it's all Playwright. Yeah, under the
right.
covers
So if
anyway.
you're using it, if you built your front end in Lovable, can you point, would you use it in conjunction with?
Yep. Anything that is visible, it's basically a headless browser. I think you use Chromium, if I'm not mistaken, and it basically allows you to sort of quickly and easily interact with websites. Now, what's cool about the way that they've done it, they've got this system that essentially allows you to actually, you know what? I'm going to just quickly share, just to jump around here, since we're getting right into the exciting stuff here. So I've reorganized the page here to be a little easier to navigate. So there's lots of areas that will expand and collapse. But if you go and you look at Claude-Flow browser, yeah, here's the browser automation. So this essentially, this is I did it as a separate module, so you can install it, and you've got different quick start capabilities. I've added. I'm hating on MCPs mostly because I don't really like the Linux Foundation, just to be honest with you guys, and it gives me a sort of outlet for complaining about things that I see. But I obviously included an MCP because I guess that's what you do in 2026. Security integration, here, and then if you want to see the full documentation, it's right here. I'll pop that in the text chat for you guys. But yeah, I'm using it, so it's again works for me. But whether it works for anyone else, I guess we'll see. But so a few things I'm doing here. I've included the security system. So one of the biggest challenges you're going to have with any of these automated sort of browser-based systems is prompt injection. It's fairly easy to take advantage of a browser swarm, like really easily if you know how to do it. So I have built-in security. So it'll handle URL validation, it'll auto detect phishing, it'll strip PII, it handles the SQL injection, and a bunch of other stuff as well. So this is what, to be honest, I don't know why these agentic browsers like Comet and others aren't using this,
Agents
but I
are.
am. Yeah. So it works pretty good. So you can see the general use case. You can see and this has more details on memory and core concepts. So agents, basically it's a swarm of browser agents in the simplest terms. Just point Claude at it. It also works well with the testing system. So if you go back here for a moment, I've got another library. Where did I put that? Testing. So those two essentially can work together. So I'm separating a lot of the stuff that I'm doing. So now you have deployment package, you've got the browser package, and they all kind of work together if you want to sort of string them along. But one tests, one validates, one deploys, and they're kind of part. You can do it as a pipeline if you want. That's how I'm using it. And you could probably see those in my GitHub folder. Workflows. Yeah, you can see them in there. You can see the V3. You can see my workflows if you're interested in that kind of thing. How I'm doing it. I'm using PNPM, PNP, yeah, PNPM. But yeah, kind of how I'm doing it there. Lots to cover today though. Before we do, what else is going on? What is everybody up to? I see lots of familiar faces. Thanks for tuning in today. Rob, do we have any updates we need to give on
Yeah,
anything?
we've got the first Vancouver chapter kickoff is tonight. Excuse me, 6 p.m. Pacific time, and we are just lining up as well Budapest, and so those dates should be solidified in the next week or two, which is really neat. Then Nick, I think you've been in touch with some folks that have some events coming up as well.
Yeah, we're just trying to nail down some times. Chicago, Charlotte, yeah, like Amsterdam,
Amsterdam,
Hamburg, Germany. There's a couple others. Have to go to my list. Halifax, that one's solidified. So yeah,
coming
it's
together.
starting to come around.
It's gonna be a busy year.
Yeah, everybody wants me to go to their conferences. I'm like, if I went to all these conferences, I'd never get any actual work done.
Right.
So, but I was telling Craftsman earlier, I am going to Bangalore. I will be there on the 6th to the 5th of February. So I guess I will travel. I guess if the money's right, I suppose.
I just want you to be my agent.
It's agentic. Like a real person being an agent. Yeah, that sounds great.
No, it's because you wrote the thing about agents the other day on LinkedIn. You must not have saw it. I wrote, I'm looking for an agent.
Oh, no, I missed that.
It was a joke in the chat. I guess you didn't see it.
Yeah. I'll keep my eye out for it. What else we got? What else? Again today I've got a new idea. And it's super nerdy. Actually, Colby will probably appreciate it. I wanted to do a new novel form of mathematics and a ability to sort of mitigate hallucinations and other things. So it's one of those, like, people keep asking me, how do you go about building something end to end? And I got a few messages recently, I want to know what your process is to get from idea to completed something. So, and being I like to build crazy things, I thought I might show you guys sort of that idea. And then we'll implement it, and then we'll fool around with some of the other capabilities in these systems while I do. But yeah, so again, if you have any questions, again, feel free to interrupt me. I'm always happy to go on a tangent here. But this is the Vibecast, so we're gonna vibe. All right, let me find my gist here, and where we are. Too many windows open. Yeah, so for those that are interested in finding the latest and greatest slightly before I do it, you can check out the gist. So this is what I'm going to attempt to build today, and it uses the concepts of an ADR and a DDD. So so first of all, I need to explain to me in a way that was meaningful in English. So basically, most systems are trying to get smarter by making better guesses. I want the system to basically be sort of to more inherently understand uncertainty. So by looking at kind of the structure, the underlying coherence of the structure itself, which is actually something that Jed was mentioning before we started the call today. Actually, just make sure I'm actually broadcasting this. I'm kind of all over the place here. Sorry, guys. Yeah, I'm broadcasting. We're good. Never mind. So basically, I want to use a new mathematical, and this is something one of my colleagues, Roger, was telling me about, is this kind of mathematical formulation. And so I wanted to take it's a complicated series of math equations that basically allow for a kind of architectural quality, a kind of compute ladder, a kind of hierarchy of needs for the compute, as well, and the governance that provides a kind of immutable policies. Basically, I'm attempting to keep the system sort of on point. So what am I trying to do? Anti-hallucination. I want to do financial market stability, signal gating for neural trading, that kind of thing, fraud compliance, and I want to be able to sort of define all this within the structure of my vector environment. Advanced sort of robotics. This is probably up Martin's alley. Medical decision support. So I need systems that will not lie to me, that are completely 100% deterministic, repeatable based on a seed, and inversely provides me the ability to see everything I don't see and understand it in different ways. So security systems, distributed discovery, and lots of different things. Machine self-awareness for anyone looking at sort of cognitive type processes. Lots of different ways to use this. Ultimately, what I'm really trying to do, and I'm going to sound like a total nerd saying it, as you can probably tell, I'm a big, Asimov fan. I literally the co-founder of the foundation, and I hope no one's working on the second foundation. But one of the concepts in that book, and I guess it's a TV show too now, is this idea of the prime radiant. So I'm like, oh, how can I build? Like, I built the foundation, I built all this AI stuff, I've got all these sort of self-aware. I built a prediction system, right, that literally attempts to predict the future. So I'm like, okay, the only thing left to build at this point is the actual prime radiant. So that's what we're going to try to build today, is the prime radiant. So if you don't know Isaac Asimov or whatever, you got to read the book. But this is the structure. So this is a coherence engine. Again, I'm way out in left field on this, but what's important here is the structure. So this is using the ADR, right? So you get the context, the vision. Most systems try to get smarter. So you can see that the initial sort of text I had up here is feeding into the actual ADR. Here's the decision structure. So it's using this sheaf. I'm not even going to try to pronounce that, which is basically a kind of validated witness. Now, if you believe in the idea that reality requires the sort of observation of something, meaning like, I think in like quantum physics, if you don't see it, it doesn't necessarily exist. And that's how, it's some sort of like causal loop, essentially. That's what this is doing. So it creates the application, a coherence level that has different lanes for reflexes and retrieval, and various calculations. Then I want to integrate it with all my other crazy, just to see what else I can do. So then it looks at all the different sort of crates. Remember, each of the things I build is separate from one another, right? So we've got different components, and then how those all integrate. Lots and lots of stuff here, and you guys can check this out. I'll pop this in the text area if you want to point your plot at
That's
it.
the package that I showed you, Rue, that I have, the UDAG, you observing the universe.
Yeah, it's a good
Same
idea.
concept.
All right, yeah, exactly. It's the idea that if you can observe it, measure it, validate it, then it potentially exists. Right, now I
100%.
gotta find. Now, where the heck did I put my, here it is, root vector. Okay, I guess switch to a different screen. No, I'll just drag the screen down. Too many monitors. All right, so this is on the Mac Mini, and so here we are. I create the ADRs. So we're gonna go in here and we see ADR 14, and I've imported the ADRs here as well, so it's nice and fresh. Why is my vector not working here? Oh, the vector works in this one. Oh well, I'm not gonna worry about that. I probably need to restart Claude. I can see what I'm looking at is right here. My vectors are not showing up. There was some weirdness on the Mac. I had to rebuild the status line, but regardless, you see that I've got the Claude here. Now the only thing I'm going to change here is I'm going to just make a quick change, and we're going to call it what we call it, the Prime Radiant. Prime Radiant. So I'm going to go full as and off here, and we're going to call the crate Prime Radiant and deploy a swarm to fully implement, test, validate, benchmark, and optimize. That's it. It should know at this point everything what that means. So I'm calling it the Prime Radiant and deploying a swarm. I'm not saying how many instances. Actually, you know what I'm going to do? I'm going to use a hierarchical. I can't spell hierarchical mesh. Whatever. You don't know what I mean. Let's see what happens. All right, so I've got all the tools, everything going, and I've got this ADR. I've got all my stuff nice and organized. And okay, so okay, so using the hierarchical mesh, strategy specialized, which makes sense. 12 agents. Okay, guess it says it needs 12 agents. We'll see what that does. It's quite a decent sized project. Now, I don't know if anyone else is seeing this. You see these little numbers that are popping up? Am I like?
Yep,
think-
you're not. It's a problem with the update with Claude Code.
Do we know how to fix that? I've been trying to fix it. I'm not sure how.
Somebody in the chat was, but I haven't been able to. I haven't spent a lot of time on it, but I haven't been able to fix it either. I don't know if it's Mac related.
Roof.
No,
also,
it's not Mac. It's not Mac related. I see it on all the. Sorry, is that Manjweep?
Roof, this is Mandeep here. Yeah. Also, the issue with the tool naming, the slash thing, the issue I had raised. Is that relevant, do you think? Because I think whenever I download now NPX and then try to invoke MCPs, Cloud Desktop just would not recognize it. It fails absolutely without the dashes on.
What's your
So,
what's
issue
the
number?
issue? Yeah, give me the issue
number.
give me the issue numbers.
Give me a second. I am going to give it to you in a second.
You guys can watch me do like real time bug debugging for Claude Flow. So now we're looking at my Claude Flow environment. I've been fixing bugs all morning. Thanks everyone who's been sending me bugs. Nothing major, luckily. So what we're gonna do, and I just fixed up all the my CI/CD pipelines, so they're all up to snuff. Now I could probably just go find Manjweep's. Let's just find that.
Sorry.
Get
On my mobile, so I'm just searching.
no, I got it. We're gonna.
I've included the screenshots and everything, like how I fixed it locally. I've included that.
All right, we've got, and you are eSwan, so 169 and 167. Oh no, Manjweep, you're number 60. You're 966. Is this the slash one you're talking about?
Yes, correct.
All right, so I'm gonna bring this up so you guys can see it quick. So we'll just take a look. All right, so this is Manjweep. Noticed Claude Desktop was complaining today with errors like should match. It went. I haven't seen this error. Doesn't mean it isn't a thing. All right. Remember these screenshots aren't visible to Claude Code. So the reason I haven't fixed it is it hasn't been able to see it. So I'm gonna have to try to describe it in a way that it can see it.
That's my solution. If you go up, that's how I solved it. I basically renamed the hyphen with yeah.
Okay. Well, let's point it at this and see what happens. 966. All right. View 966. Don't fix. I'm mostly just interested in what it's doing. All right, don't fix. While we're doing that, we're gonna jump back here for a moment. Yeah, like I said, I've been cleaning this up as best I can. I'm using this. It works amazingly well. The other one that I've been mildly obsessed with has been the root vector. Last night I basically cleaned up the entire structure. Similarly, you can see I'm using a similar structure because they're based on similar code. But you'll notice that I've organized this quite a bit better now. So now I've got all the crates. There's an incredible amount of stuff here. I'm like, when I was organizing it last night, I'm like, it's just a ton of stuff here. The RV light's been, I'm not sure why that's saying not found. Yeah, it is published. I probably need to fix that. Couple issues there. Yeah, I'm not sure what's going on with those. But these are all WASM. So everything you see basically in the npm packages can be run in your browser as well. The crates, this is all the crazy. So this is the most foundational part of everything that we're building. Mincut and all the different tools. This thing is become quite the beast. Here's the DAG for anyone looking to do DAGs. RV Lite, if you want to run this in your browser, this has been really popular as well. Sort of all the crates. So basically, you can run everything in root vector in your browser on the client side. So you can see that. And if you're looking at the really crazy stuff, well, it's all kind of crazy, but if you're looking at the really crazy stuff, check out this XO AI folder. This is basically, I did a simulation for the next 50 years. And then I based on that simulation, I'm like, how does all this tech evolve? And what does the world look like in 50 years? Then I ran, I think it was 10,000 simulations of what the future in 50 years looks like. Basically, what am I building in 50 years from now based on what I've built over the last 3 years and then simulating the next 50. And this thing popped out. So it came up with a whole bunch of crazy things. I'm not even going to try to explain what the heck it is. Bunch of crazy. But if you want to try that's kind of a cool spot. The other thing that's kind of useful is I created a scientific OCR engine. So I trained an OCR engine specifically for sort of more scientific related data like latex and math equations, calculus, that sort of stuff. So it kind of give you an idea. And the last part, and probably the most exciting part, is I published a model. So the model, and hopefully I'm not going too fast. I'm jumping around here a little bit. So before we do, let's check in on what Manjweep's use of slash Manjweep problem slot root cause tool definitions. It uses namespace separator. Oh, Manjweep, is this a problem specifically in antimatter? Is that what you're using?
So I started with anti-gravity first to look through Cloudflow. It did the NPX, but then it couldn't actually invoke the MCP. So I went to Cloud Desktop and I basically tried to start up in Cloud Desktop. It then failed completely with that bit. So then I kind of had to change it to the slash, and then it started. Cloud Desktop independently started recognizing only after I changed the slash to dash.
Okay. Publish both. So remember, I've got two parts of my npm library. When you watch me make these changes, I'm mentioning the umbrella. The umbrella is the basically the core npm library. So npm clod-flow would be the umbrella, and at clod-flow /CLI, for example, would be the CLI. So the MCP exists within the CLI. So I'm going to say publish both and CLI MCP libraries with fixes, validate after publishing. All right. So
sorry, what is the umbrella? Did you say? Sorry.
The umbrella is the core library that connects to all the other sub libraries. So the umbrella covers everything. So
I see you have 1% there until auto compact. Are you worried about it? Are you clearing context on Cloud
Not
Code?
worrying about it. it'll do what it's gonna do. I'm starting a new process here. I probably should have created a new Claude instance, but I was working on similar bug fixes, so I'm not over, so it's already kind of in the right state of mind, if you will, to fix these sorts of problems. So I'm not. It's compacting right now, obviously, so it's fine. All right, so we jump back here to Rube Ultra. Rube Ultra. So there's a new model that came out recently from, I think it was MIT, that looked at something called an RLM. And the RLM is, so this is based on the concepts of an RLM, or I guess recursive language model. Yeah. So I gotta go. Actually, I should probably go right to my main library for that. I'm gonna actually show you that straight up. It's vector. Oops, that's weird. All right, so in Groove LLM, in the crates, there's 2 crates, and then we've got, a lot of stuff in here. There we go, Rube LLM. So this is essentially an entire inference engine. So it's using the Mistral RS backend for serving the system itself. Of all the tools that I've seen recently, Mistral RS is by far the most useful if you're doing anything involving sort of serving and creating and optimizing your own personal language models, embedding models, or other various kind of reasoning models. It's awesome. Like I don't you know what they built is spectacular. So I built it on that. That allowed me to essentially create the RLM components. And what I'm trying to do is give you an idea of what the RLM actually does. I might have to jump into Claude to give me a better explanation of that. So let's jump into that for a moment. All right. Too many screens. I'm gonna share my other screen again. I'm really jumping around today, guys. Hopefully it makes sense. All right, so there we go. This is the RLM. Okay, so the RLM, this is a system that makes AI smarter by breaking down complex questions and searching memory for answers. Now, I'm going to do my best to butcher what it does, but for me, what I'm doing is I'm replacing the context window of the language model and using my own vector and graph storage system. So that essentially gives me infinite context. And then the system is capable of traversing that infinite context to find exactly what it needs to solve the problem. So when you look at like a language model and you kind of look at it from the most basic point of view, it's essentially a kind of vector storage, right? And then the system is then using a kind of combination of a sentence transformer to go to and from that kind of vector space, right? What is it? It's this. Give me the answer. Now that generally in a pre-trained model is everything that exists in the training or some variant of everything that existed within the training, and then trying to determine the most probabilistic result based on the question being asked. And it works pretty good. But the issue is it's hard to maintain, it's hard to retrain, and it's hard to optimize after you've trained it. My approach basically uses that, but also then optimizes it as the system is actually operating against it. So it's using all the same sort of characteristics that I was telling you guys about, kind of self-learning and other characteristics, and then applying a kind of language model to it. So it decomposes the different parts and what the meaning of each of those parts. Then it goes and finds those parts. Then it synthesizes multiple answers potentially to it. And this is particularly important if you've got a complex data set. So think about like DNA analysis or a repo of millions of different documents, right? And one of the challenges of very large indexes is if you want to do a large model, it's going to be billions of parameters, or if you want to do a large vector, it's going to take a lot of compute and resources to basically build it, and re-indexing it becomes problematic as well. Now, my min-cut means I can instantaneously re-index, because the min-cut system basically allows for a real-time re-simulation, restructuring of the data set itself. And then I can then reflect on it using various forms of attention that I apply to it that sits independently of the attention of the words themselves. So that provides a really interesting mechanism to do, again, recursive decomposition, breaking complex queries into simpler subqueries. I can route those using TinyDancer and other components. I can get really, really fast retrieval using the HNSW to go and do that in milliseconds. I can do quality scoring, ranking answers, and having secondary systems understand it. So essentially what it can also do, or what it is doing, is simulating different possibilities in as part of the language model itself. It's kind of simulating a world model, if you will. And then it can reflect upon itself. Now, all of this is, in this particular example, I'm doing in a tiny little model, right? This I haven't fully quantized. It's about 400 megabytes, but I could get it down probably about 60. Now, so what are the speed benefits to using Ruve LLM and RLM? And how does Ruve Ultra how does the Ruve Ultra work? Yeah, well, we're gonna let that cook for a minute. Let's see what's going on here with Cloudflow. Cloudflow is still fixing. So I'm gonna fix SpongeWeep's issue here while that's working. All right, so let's go back here for a moment. And this is the ADR that I started earlier. And we see here, we can go all the way to the top. It did a compression at the beginning. Both have been updated. Okay, there we go. That's lots of information. Let's start at the bottom. Design principles. All right, let's look at the crate. Prime Radiant. All right. Lots of stuff being built in there. Look, it's looking good. We got substrates, we got MinCut, we got hyperbolic, we got all the tools. What I like about the new version of Cloudflow is how it kind of gives you incremental updates. See how it's stopped? It's not trying to constantly sort of tell me what's happening, where the V2 was always like kind of always running and flickering and just kind of busy. This stops and waits. And then when the different background tasks, there's currently 4 remaining. See these 4? When those are done, it'll then update and it'll say, okay, this is done. It's done 35,000 lines of code. And the fact that I just did 35,000 lines of code in the time it took me to describe what the RLM was is actually pretty crazy too. So now we have key design. All right, that's looking pretty good. I'm gonna jump back to the other. Nope, that's not what I wanted. This one is in this one, I think. All right, back to the RLM. So speed and benefit. Again, everything I'm doing is trying to optimize for speed, and efficiency, right? So the HNSW search, is fast. These are the numbers it always gives me, but it is fast. Flash attention, this pays attention to what's important. And again, we've got a bunch of different ways to do that. And the system will auto select from all the different attention models that I've made available to it. I think I get like 39 different attention models. Speculative decoding. So draft model predicts ahead and main model verifies. This is the fact that it's predicting the logical response before for anything it's being asked of it. Then based on what it needs to know, it learns instantly. And it does that in like microseconds, right? So it's learning, it's adapting. And then the cache and repeated queries are served from the cache itself, which is in this case a vector style cache. So according to this anyway, traditional LLM queries are 2 to 5 seconds. That's actually pretty fast, even for traditional. It's only that fast because I'm using a small model. So bigger models typically are slower. Mine are my system is, according to this anyway, is 10 to 50 times faster. So again, it's meant to sit on the edge, it's meant to sit in your browser, it's meant to sit in places where you want to get that information really, really quickly, and you don't want to have to wait for the long time it takes a language model to reason and go through all that process. So when you look at like the heavy thinking mode in Claude or Claude Code or Chat, whatever. That idea that that you have to wait like 2 or 3 or 10 minutes for the answer. Now that can all happen in seconds or less is the idea here. So complex queries, create, React, Vue, Angular for use case. This is kind of the sequential steps you'd see in a traditional model, right? Search memory, search, for this, that, and the other thing, and then give you the response. So I'm doing it slightly differently. I'm checking the cache. I'm using parallel searches, means I'm doing all of it once. And the irony, if it's an irony, is these systems, especially GPU-centric language models, are actually not that good at that type of sort of diverse parallel sort of use case. When it's doing something, it's kind of doing everything all at once, but it's not doing different things concurrently to each other. The GPUs are like, do this one thing, but do it like a billion or trillion times all at once and give me the best answer. But sometimes you just want to do 3 things or 10 things or 1,000 things in parallel and then bring it all back together again. And that's what this does a really good job of. So then it generates a new context based on that, and then it brings it all back together again. And that's what my model is doing. But this model has been trained specifically to understand the nuance and the structure of Claude Code and Roov products of various sorts. So I trained it on all the structure of the Roov vector, the agentic flow, and the Claude Flow library. So it doesn't know everything, but what it really does know is it knows exactly how my system needs to work and how it needs to be structured. So it's optimized to do like coding tasks and spawning agents and learning and adapting and getting better and those sorts of things. So you see here that I published a few different models. There's different structures. And it's cool. I can adjust. What I like about language models too is I can adjust things like temperature and top K and top P, that kind of stuff. Routing accuracy. So you can see that, and this was a question Jet had earlier as well. Like, how do I know how to go from like question to answer and back to sort of result, right? Like the magic that happens underneath in terms of the math. So what I did is I created a benchmark to try to measure that more efficiently, and I was able to get a few extra points here and there. Performance numbers. I'm actually not using an M3, I'm using an M4, but whatever. So when you ask Cloudflow to do something, the Roov Ultra agent embeds the task. The HNSW finds similar tasks, so it learned based on what I did. Keyword first routing picks the right agent, and Sona learns from outcomes for the next time. So if I do the same thing, it's going to be faster, better, and at the same question. So essentially, if the answer resulted in a problem or an error or something that wasn't right, it's going to learn how to do it right. And the next time you ask that same question, it won't give you the problematic response, which is important. All right, let's jump here for a sec. Oh, Primary Engine is ready for development and testing. All right, that was fast. What the heck is it? Keep it simple and 200 words. All right, so the swarm works great. You can see how I've gotten really good at making complicated things very, very, very quickly. So this was a 12 agent swarm. All right, so okay, it's a bullshit detector for AI systems. Most AI uses confidence scores. I'm 95% sure this is correct. The problem is AI can be 95% confident and completely wrong. Hallucinations. You're asking a system that doesn't know the right from wrong to tell you whether the thing is right, right? And that's the problem when you have these kind of BS confidence scores that you ask the LLM to generate for you. It's like, hey, are you confident in the thing you made? Yeah, of course it's confident. It literally is giving you the most probabilistic output. That confidence isn't based on anything grounded. So with the prime radiant takes a different approach. Instead of asking how confident you are, it asks, does everything still make sense together? It's the anti-pattern that I love so much. So think of it like a web of facts connected by rules. Fact A says X and fact B says Y. Rule X can't be both and be true. It's math. Math can't lie. So the underlying principle is a really crazy algorithm that basically grounds it in mathematics. It's the prime radiant. It's a combination of using a irregular sort of prime number. In this case, I'm using 7, combined with pi, which is a constant, a known constant that allows me to sort of better understand the sort of inflection of both. And then there's a gating mechanism, low energy acts freely, so reflex, rising energy slows down, checks more sources, and high energy stops and escalates to humans. You can see how this all kind of relates to some of the other stuff I was showing you a moment ago as well with the RLM policy. So now that I've got that, I could potentially integrate this with the RLM, which is exactly what I'm going to do. So how can we integrate this with the Roov LLM and RLM capabilities? And where the heck did we put that? I think I put that in my crate, so I'm just going to remind it where I put it. Roov LLM, boo boo boo, there we go. Don't implement, just update the ADR. So this is going to allow me to take the already crazy Roov LLM system that can do all the stuff I was telling you about earlier, and then create a new anti-hallucination component that will run in the background that provides the ability for the system to be 100% verifiable, validated, so I can validate each step of the thinking process that happens sort of under the covers. And every time I do a change, it's doing compacting. So I'm going to jump back here. What else we got here? Actually, let me pause for a moment. Any questions?
I have one. I can't raise
Sure.
my hand, but I have one. Yeah. Just slowing down and rewinding a bit. So this is great to see what is created, but like, did I understand you that obviously you've come across the sin of the idea, right? So I'm just wondering, how did you just take a paper and then you effectively ask Cloudflow
Oh,
to?
Roger gave me an idea. So
Right.
Roger's the guy I'm doing the chips with. He's pretty clearly a genius. If he's on here, don't let that go to your head. But yeah, he was we were talking about sort of deep mathematical concepts the other day, and he was telling me, he was telling me about this sort of inflection of, 7, basically odd numbers and prime numbers, and how we can use those as a mechanism to do some really interesting sort of mathematical. I don't know what you want to call it, like, it makes things more optimized, if you will. So then I actually just went into ChatGPT for this one. I wasn't using Claude because I didn't want to max out my Claude. So I went to ChatGPT. You guys will get a sneak peek of what my ChatGPT looks like. All right, here we go. We've got, yeah, so he told me about this thing, and you guys might know more about mathematical concepts than I do, but he told me about this thing called Karasuba algorithm. So that got me thinking, okay, what the heck's the Karasuba algorithm? He said, you got to check that out. And I'm like, I've never heard of that. So let's go check that out for a moment. It's the Karasuba algorithm is a fast multiplication algorithm for integers. It was discovered by some guy in the 1960s in divide and conquer algorithm. So what I discovered quite quickly, it's interesting, but it's kind of computationally heavy. So obviously ChatGPT knows all about me, right? I've got all my memories and all the things in it. So below is the state of the art, so research state of the art and theoretical concepts based on previous. So now it's telling me about polynomial lenses and all these various things. And it's telling me what I need to know. Then I'm like, okay, how am I going to actually integrate that into what I'm doing? So does this project really solve this? And then I'm like, I did this sublinear thing a while back. The sublinear is a diagonal structure, so it's a little bit different, but I'm trying to do crazy math with it. And it basically said, no, it's not going to work. It's not the right approach. And then I'm like, okay, what should we implement based on state of the art and theoretical principles that we can build today, but based on 25 years in the future? I love the idea of kind of like reverse engineering the future. And if you look at what I'm building, it's totally reverse engineering the future. So then it says basically build systems that do blah blah and dynamic signal sites, knows dynamic min cut again. It likes, it knows all about me. It says I can use my Postgre. 25 why is it 25 years ahead? Frontier. okay, I've already built this. Like you're just telling me what I've already built. We need to think more profound beyond the limits of possibility. I keep in mind I'm writing this at like, midnight or something. So I'm, sitting on my phone or whatever. So I'm guiding it. Sounds like I've implemented root vector in just a different way. Yeah, yeah. You're seeing my conversation. Now I'm like, okay, can I use the 7 with a pi constant to create the prime radiant? Right, back to my, depends on what you mean by prime radiant, blah blah blah. And remember, I've modified Claude, or sorry, this is ChatGPT, to use that kind of thinking structure that I like so much, that basically questions what I'm doing. Like you can see that my result is pushing back against some of my assumptions, and that's what I want it to do. I don't want it to be a sycophant. I want it to basically call me out on my bullshit. So, but then it said here, that there are some options you can do to use base 7 with the pi digits. Oh, that's interesting. So the sort of math object I can implement in RuVector. So then it tells me about this sheaf, whatever, Lippian coherence. I'm like, oh, that's
Laplacian.
interesting. Yeah, there you go. Laplacian. You guys, I'm a self-trained guy, so you might have learned this in computer science. I was too busy starting companies, but this is new to me, and so this is telling me about the math and the structure, and so I continue to ask questions why this fits RuVector specifically, and this is where it got interesting. Well, it tells me that I can use my edge for a kind of contradiction current, and that's a really then and if you followed me at all over the last few weeks, you know that I'm really about contradiction right now. I'm about the inverse model. I'm about the antimatter, the opposite, the dark matter that exists, that connects everything but isn't overtly obvious. So this to me starts saying, well, I can create this kind of refusal gate, this kind of inverse model that allows me to understand. So then it's guided me through it, doing this other stuff, so on and so forth, and creating an ADR. So now I asked it to create a detailed ADR. Now this ADR isn't perfect. This is a nice structure because it gives me some of the math I needed to do the witness and other things. Then I pop that back into in here, and you'll see that I went and I've got all this other stuff. So when you look at this ADR, which is actually the ADR I posted in the gist, it now knows about all my other stuff, right? And that's the important part, right? I'm building on top of building on top of building and modifying and integrating and reimagining all these different modules that I built previously to do new and interesting things 25 years in the future, if you will. And so now it's giving me this kind of universal constant object, AI agents, facts, hypothesis, beliefs, finance and medical and science, because I gave it I gave it the sort of, here's the areas I want you to focus on, things that are important to the projects I'm doing, why this works, and this is being explained as much for me as it is for the AI. I have to understand as best I can what the heck it's doing. So, yeah,
On the ChatGPT conversation that you were on before, the area where you asked it to, based on your obviously building and conversing, you asked it to create the ADRs, right? So if we go to the bit where you asked it to build the ADRs, where it said ADRs and DDD, I think you said,
yeah.
right? So create the detail. So the output that you are getting from here, is this the exact output that is there in your
No.
Claude code? No.
N-
Okay.
No, it isn't. No, it isn't. This was the initial ADR that I used to create my more in-depth ADR. So what I'm not showing you that part of like where I said basically I created a initial ADR file somewhere or other. I think I might have just copied and pasted it. And then I basically said create me a new ADR. But before you do, review all the crates, NPMs, and example files in this repo and integrate the existing to take it to the kind of next level, right? And that's what you're seeing here. So now we have this kind of decision process, LLM guards, fraud detection, compliance, coherence gates, knowledge, all these different parts, GNNs. So it's using, different parts of the sort of engine that I have available. Here's the integration matrix. These are the different crates that I've, nervous system, the hyperbolics, the min-cut. These two are particularly important in terms of what I'm doing right now. And you can see it goes and goes and goes. At which point I'm ready to go and implement, which I showed you a moment ago. And that's what's happening here. And all right, ADR has been updated with the Roove LLM integration. So now it apparently works. I haven't really tested it, but according to this, it works. So now we're going to take it a step further. We're adding the 5 integrated model of uses sheaf energy instead of pattern matching, a single audit trail for inference, reasoning bank patterns, agentic memory, some other various things, 7 new ADRs, 16 through 22. Where did it put those? Oh, ADR. Okay, so it's creating those in there. Let's just take a look what it's doing quick. ADRs. You know what I'm gonna do? I'm gonna create the new ADR MDs with yeah, that's it. Create the new ADR MDs. What it did is it added it to number 14, and you know what I'm gonna do? Create these in a sub folder. I don't want to mess. These are sort of sub to the main, so I'm gonna create those in a sub folder so I don't make too big a mess of that folder. I'm always trying to clean up my docs and the various things that exist, right? So you can see here it's pretty well organized at this point. So I don't want to make it messier than it needs to be. So there we go. Now it's gonna add those, and then I'll review those in a minute. Let's jump back to Manjweep's one for a sec. So I'm gonna share my other screen. All right, Manjweep's issue 966 is complete. It looks like it's been published. Updated the distribution. Build compiles, MCP tools, no tools with slash. Oops, with no tools with slash found. Works. The agent list, memory list, hooks list works correctly. So there you go, Manjweep. You can confirm or not, I guess, but it's been published.
Thank you. I'll do that this evening.
Yeah. I'm just because I'm confirm the npm umbrella. I know what it has. I'm just going to confirm it anyway. And CLI are published. Create PR. Now, just as an FYI, you can change who and what is being shown when this is published. This was a question someone asked me last week. And so now when anyone uses this by default, it's going to go to Claude Flow as the publisher, not Claude Code. But you can change it and make it your own. See this attribution? If you add that attribution to your settings.json, it will stop saying it's been published by Claude. There's a lot of reasons why you might not want to say it's published by Claude in GitHub. That solves that problem. Now, just as an FYI, it's going to say it's published by Claude Flow now, but I figured it's better that it's public. At least it's getting credit to my system and not Claude's. But if you want it to be yours, just edit that and you can make it your own. Just put in your own email address, and the email address has to match the repo that you're associated with. So just make sure it's the whatever you signed up for GitHub. But that will you just add this.
That's a great
And
change.
work. Yeah, because again, I don't want it to be Claude. Claude gets enough cred. They don't need any more cred.
Roove, Jose and then Nolan have had their hand up there for a bit.
All right, Jose, how's it going? Oh, did we lose you? And oh, you got
You're
Nolan,
muted.
how's it going?
Good, thanks. How you doing,
Yeah,
guys?
sorry, I was mute.
Go ahead.
Can you hear me now?
Yeah, how you doing?
Yeah, pretty good. I just want to mention something that I don't want you to miss in this one. Remember, I opened the first ticket in Root Vector, and it was for the implementation of the refract. The refract is a better way to do frag.
Yeah,
to do RAG.
it's fully implemented. Have you tried it?
No, I was trying to, but I didn't know how to. I didn't know how to implement it properly. So I tried a couple of times. So I think this will complement what are you doing right now. So you have it on
I've already-
the
I've
example.
already built. Yeah, it seems to work.
I mean, but how you? I mean, is part of the system already, like from the root vector?
Yeah, it was your idea.
Correct. But then
Yeah. Here, let's go
Yeah.
here and refrag. I think it was right here.
Yeah.
Yeah, this is the refrag pipeline. This is apparently I built this 2 months ago, but yeah, it all works. I use it sometimes.
Because I was trying to put refrag and recursive LLM, and
Yeah.
but
There's so
I was
many bits and pieces. You can like I've created you like a Lego, a box of random Legos you can put together and assemble in any way you want. This is what this is. It's a rando box of Lego.
correct. But then, how can you confirm that it's already implemented in root vector?
Well, it's right
That's my
here.
question.
Yeah, there's a whole section dedicated to it.
In the example or inside the ADRs?
It's in the main page, just the section called refrag. And
I
last
don't
week's
see-
project.
I think you're sharing the wrong screen.
Oh, am I sharing the wrong screen again?
Yeah, I think so. That's why I don't see anything.
Oh, sorry about that. Let's try again. Yeah, so I'm on my RuVector main page.
Okay.
You see,
Okay.
there's a refrag section.
Okay.
Yeah,
Because
and
I think you updated the README file. Now I can see it, but before it was not there.
yeah, and here's the full README for the pipeline.
Alrighty.
Yeah, you see, I actually built this 2 months ago. Yeah, two months ago.
It was that long? Really?
Yeah, time flies, huh?
Jesus.
Yeah, I know.
Good. Okay, good.
That was a random Thursday as well, but it seems to work. There's so much stuff. I don't know. It's and here's the issue for the full. I think was this your issue?
Yeah, that was me.
Yeah.
Alrighty, thank you.
We did that November 23rd. We're so
Yeah.
ahead of the curve on this stuff. Like, oh yeah, we did refrag 2 months ago, and everyone's like, this latest thing just came out called refrag. I'm like, is that really that late? Is that the late? We probably did it the same day that this document came out, right? That's kind of our thing.
Almost. Well, I think it was like 4 days or 5 days after.
Yeah, it's because people keep telling me, "Have you heard about this bird thing?" I'm like, "Yeah, we did it last week." It's like,
Okay, thank you, Roof.
yeah, here, like that bird. By the way, the bird thing's just still gets me going. It's like 7 cents. It's 7. I should have done 6, 7 cents. But my kids told me. But I don't know why it needs to be 6, 7 cents. But anyway, bird calls, fully functional embeddings. You can create an alarm system based on
If you
crows.
if you inspired them to start coding, call it 6, 7 cents. It's
Yeah.
going to hit. It'll be like the top of charts at the moment, 6 or 7.
Apparently. Yeah, it makes no sense to me, but they like it. Nolan, how's it going?
South
Good,
Park.
thanks. All right, guys. Happy New Year. Two quick questions. First one is a quick one. With the root vector PG Postgres extension, what is the best database to install that into? I've typically used Neon, but I don't know if they allow custom
Neon
extensions.
doesn't work. No, Neon. It sucks that they don't allow custom extensions because that's the most exciting part of Postgre right now. I'm using Postgre 17, and I'm using it on Google, the Google VM.
Okay.
And then I do like incremental backups, generally once a day. Depending on the use of the system, I might do several times a day, but I'm cheap, so I do once a day. And locally, I'm just using Docker. I'm using the Docker version, and I just spin up the Docker instance, and then I expose the API.
Okay. Thanks. A second question, just thinking about the RLM approach, and I guess maybe it's just a general question relating to root vector. But if the system is learning through root vector, how do you know when the learning is correct or not? For example, let's say I wanted to use root vector for a image prompt generation system that always ensures that the input prompt of for an image generation is quote unquote on brand, whatever that is defined as. And assuming that the system can learn and know what a more accurate result is through root vector, how does it know when it's accurate or not?
How does it know when it's accurate or not? Well, it depends on what problem you're trying to solve and how you're grounding it. And the problem with self-reinforcement is if it's not guided correctly, it could be self-reinforcing the wrong things.
Right.
And it depends on the data that you're using as a kind of complementary, grounding for it. So often what I use the Google grounding engine, which allows me to basically get the, verified data, similar like how a LexisNexis might work. And that provides a kind of secondary grounding that bases it in reality. Now that's great for information that exists within reality, or our reality anyway. And the other approach is a mathematical approach. So the mathematical approach here, well, I just asked that question quickly while you're asking it. So the mathematical approach, so the grounded truth benchmarks, right? So I've got this idea of routing test cases, human labeled grounded truth. Now, that human labeled grounded truth, generally speaking, is like Google, the Google grounding engine, or some sort of web-based search that I do, or data that I've synthetically created to represent whatever it is I want to do. So, and then there's a kind of comparative benchmark to get sort of an initial accuracy, so you can see that I've got the different comparisons. Now it's saying I'm using Q-learning. There's different learning approaches. I don't just use Q-learning. For whatever reason, Claude likes to sort of go to Q-learning for most of its systems. It's Q-learning good, but it's not the only option. But this is so pattern use, task successful, Q value goes up. Reinforcement, pattern use, task fails, goes down, right? And then that can be sort of understood very, very quickly. And then similarity thresholds. Are there things that look similar? Like maybe a lot of coding activities are actually quite similar to one another. Even though I'm editing a different file or doing different things, the structure of how I do it is pretty much the same, even if the code itself is different. So this is allowing for a kind of threshold to understand similar things and how those relate. Then in the confidence scores, and this is something we're currently building as we speak, the confidence scores allows me to say, yeah, I'm confident that this is true and right. Now, what I'm not doing in this scenario is asking the language model itself to tell me what the confidence is. Is this right or wrong? And that's where this other thing that we were building is basically attempting to give me a better sort of grounded confidence that's based on a kind of mathematical integrity check. So the integrity is not defined purely based on, is this true, is this false, because I don't believe it to be true or false because it's a language model. It is true or false based on the underlying connectivity of the data and the structure and the positive or negative reinforcement itself. Which then, so what could still be BS? Here we go. Overfitting. This is up to you to determine. This still needs to be somewhere in the mix. Garbage embeddings. Well, I've got my own embedding model, so I'm pretty confident that it's not garbage. Confirmation bias. Well, asking an LLM if it's confident in the thing it just gave you, it's going to be confident in the thing it just gave you. That is confident. That is confirmation bias. You can't ask the same damn thing if it's confident about the thing it gave you. It's just going to be made up. So you never ask an LLM to do anything involving sort of confidence. It's dumb, and I see people doing it every day. It's like, well, according to the LLM, it's 95% confident that this is true. Well, that's just dumb. It's don't ever do that. So that, yeah, so we have the Q values. So
What about what
Well, I
about auditing? What about using another LLM to audit the other one? That's what I
let's
do
make their
now.
no, that's like the movie Dumb and Dumber. That's just asking two dumb people to answer the question they don't know the answer to. If you're doing any form of confidence, you can't use an LLM. They're not made for that. And they're gonna give you a confidence, but it's gonna be meaningless.
So
And then you're gonna say, well, I can ground it or whatever, but still meaningless. It's still making it up. The only way to get true confidence is to do what I'm doing right here as an independently mathematically verifiable structure that can run independently of the language itself.
any thoughts on how this might be applied to multimodal though? Like, and curious maybe if Brad can
Well,
maybe weigh.
multimodal. Keep in mind what a multimodal is. Multimodal is our interpretation of the modality. It isn't actually a different modality. When you strip away the fact that it's an image and it's a vector interpretation of the image that then is then described linguistically in the form of a language model generally, but that is not a different modality. That's the input is a different modality. It's an image, it's a video, it's a sound, and then that gets in the form of a language model interpreted into linguistic description of that thing. It's a video that has pink entry or whatever, and then that gets described. Now what you really want to do is you want to describe that image or video or audio in a mechanism that is true to its original state. So if it's audio, you want to define the audio structure, the spectrum of what the audio is doing. And that's not a bit of text saying it's loud, it's quiet, the guy's talking, the guy's singing. That's not necessarily the most useful structure for that. So back to modalities, what you really want to do is you want to define the structure of the information in a way as it more naturally occurs, not just how you describe it in a language model.
Yeah. Yeah, I'm thinking about that for like image generation and like compliance, but
Yeah,
also like the subjectivity, well, not necessarily subjectivity, but like, is this representative of the brand or the campaign or some other ground truth?
Yeah, exactly. That's exactly what you're doing. So you can see how I do it. And the reason I create this SciPix scientific document OCR system is to do exactly what you described. So I needed to be able to describe the visual modality of something as quickly as possible, but in things that are really complicated and hard for language models to understand because they don't necessarily speak in this particular language, right? They don't use LaTeX particularly well. So, and I needed to be able to accelerate and do all sorts of things. So this represents, at least in my world, the sort of image modality. Now, when you go down to 7sense, this represents an auditable modality, right? I'm translating the structure of the bird's communication patterns, and I'm structuring that into a vector form that allows me to understand the correlation between, different signals within their communication habits. A raccoon shows up, they might make a different noise than a human, and then being able to understand that the mechanism they use to alert each other when a raccoon shows up sounds and looks from the point of view of the spectrum of the audio itself different than the other, right? So I'm trying to mimic the structure of that modality more natively. And so what you're describing is similar conceptually, but implemented to solve a problem where I'm just broadly seeing if I can do it.
If I may, I'll follow through on that question about all that example you gave with the 7sense. So again, probably these are hypothetical situations you described. So the noise the bird will made with one animal or the another. But how do you actually validate? Because it will, I mean, we don't know actually what was
Well,
going on, right?
yeah, that's where Perch 2 came out. So I couldn't until the guys at Perch 2 came out with this concept last week. Suddenly they had done all the hard work for me with Perch 2, right? So once we had Perch 2, the bits in is this German? No. Yeah, so once they had this, I guess it's Google. I was able, and this was not full. They didn't. And I love when people do this because I like to be first. So they put out this really detailed sort of paper. Let's see if I can find this really detailed paper on how it works, how the structure of Perch works, but like in classic Google, their model didn't do the weights or the sort of underlying algorithms. They just sort of described them. So I took it and rebuilt it in Rust because I could, but they had done all the hard thinking and proof. So it's all based on, well, let's one sec. Let's watch the video. I'm just gonna show this one more time. Turn on the audio.
What's not to love about birds? They do all of the work in the forest: pollination, seed dispersal.
Birds are fantastic. We learn a lot about what's going on in a habitat just by listening to birds.
They use songs and calls to keep track of each other, and we're trying to do exactly the same thing, use their songs and calls to keep track of them. There's a huge conservation crisis in Hawaii. We are known as the extinction capital of the world. Almost 3/4 of our native species have been lost.
When mosquitoes arrived at the islands as humans moved in, those mosquitoes carry avian malaria, and many, many species went extinct. Most of the other birds that remain are all at high elevation, above where the mosquitoes want to live. However, with global warming, temperatures are rising, and that mosquito line is increasing as well.
Without these birds, it's just going to be the deterioration of our native forest beyond recognition. So we're putting out reporting equipment in the forest. We're using bioacoustics to estimate where the populations are and how many there are and see if they're responding to conservation action. You could manually analyze all of this data, but if it takes you 5 years to get through it, by that time, your bird may have gone extinct in that area already. So I've got together with Tom at Google to try to find some innovative ways to use AI in analyzing soundscapes in order to make really timely conservation decisions.
There's not a whole lot of training data for endangered Hawaiian birds. And also a lot of them sound similar to one another. So Perch is an AI model using Google tools that helps with species identification, but also identifying new sounds that nobody's ever tried to capture before.
We like to term it the Perch search. You can take this clip and you can scan through the hours of soundscapes, identifying a single species, lightning fast, and to detect if we see an uptick in both adult and baby bird activity in these areas that are being treated for mosquitoes.
In an ideal world, we'll be able to see these populations and hear these populations really bouncing back.
So that's cool, right? But it could have been better. So I took that and I applied it directly into the root vector structure, and I basically made it on steroids. So suddenly I could do what they were doing in, theirs was fast, relatively speaking, but mine was like exponentially faster, exponentially smarter, and self-learning. Theirs was static. So they've got a model that's pre-trained on these birds in Hawaii. But I'm like, how can I train it on anything that I can then associate in real time incrementally? So I took what they did and just greatly improved the sort of structure of what they were doing. So now I've got the ability, and I separated it into different cores. So we've got, if you want to do audio related things, so you might want to use it for maybe detecting a pop hit of music or whatever. Then I use the local embedding model because I'm too cheap to go and buy someone else's. I applied the vector structure, so I could, what took I think 300 or 400 milliseconds now is like microseconds, and a bunch of other sort of capabilities. So, but back to the original question, like, how do I know it works? I'm kind of trusting that the research team at Google knows what they're doing.
I mean, thank you for sharing this. I mean, I'm thinking of like going a step further, because I think there was one Google person, the other one is the person who's running the conservation efforts at Hawaii, right? I mean, we've been talking about AI for good and all of our things about impact or third pillar. I mean, is there an opportunity to validate this actually on the ground by reaching out to the person in Hawaii, the conservation person?
Well, yeah, we should. We should say we've taken what the Google guys did, which was basically an elementary implementation, and made it, Nobel Prize level. right? That's what these systems are capable of at this point. So we're not just improving it, we're reimagining these research papers, because these guys have no idea what we've built here, right? So they're using monolithic GPU centric or TPU centric models and kind of the old, pre-train and be done approach. And we're like, we don't need that. We've got RLMs, and we've got real-time learning and optimizations and reinforcement, vectors, latent space, attention graph structures, DAGs, all these mix and match components that take any concept and ground it based on the research that they've proven, and then amplify it. That's the cool part here, I think.
I think there's something we should put it. I think a group of us should really explore, because this will be helping us actually going back to our point about the dominant design that we talked about, right? Of Cloud Flow and all of the stuff that we are doing in the ecosystem is to prove it on the ground. So, yeah, I think this is a candidate we should. Maybe it's not in this call, but maybe we should actually consider this.
And okay, so what I'm doing now, that swarm I built earlier, I love seeing last week's project show up in the next. So again, this one's a little, I'm not gonna lie, it's a little out there. So what I'm gonna do right now, just to make it a little easier to consume before I actually publish it, and I'm gonna publish this here in a minute, and where the heck is it? It's in the Prime Radiant, Root Vector Prime Radiant. Where the heck did I put it? Oh, it's in. No. Oh, I gotta find it. A, B, C. Where the heck did I put it? I gotta find it. We'll see. We'll see in a sec. The problem with my auto git commit is that, and then I'm gonna try to discover where the heck I put it. It's in crates. Oh, it's in crates Prime Radiant. Okay, well, why am I not seeing that? Oh, it's at the top of the list, of course. Okay. All right. So what the heck did we build today? A universal coherence engine for AI systems. Prime Radiant answers simple but powerful questions. Does everything still fit together? Now, think about, does everything still fit together applied to that bird thing I just was telling you about, right? It's the anti-pattern. How does the mosquito noise affect and the bird noise, and how are they interconnected at all? Is a raccoon, having a conversation with its raccoon family, and how does that affect the birds? Or inversely, the birds, are they warning because of a raccoon? Is there a certain noise a bird makes that represents a raccoon? That's what the Prime Radiant is attempting to do. Taking it a step further, can we simulate the causal effects of those interconnected relationships? Imagine having an AI assistant that retrieves facts from a database, remembers your conversation history, and makes claims based on what it knows. The problem, these pieces can contradict each other. The AI might confidently say something that conflicts with the facts it just retrieved. Traditional systems can't detect this. Back to Dumber and Dumber. If you ask Gemini to validate ChatGPT, it's an echo essentially of itself. It's not validating anything. It's just confidentially bullshitting the same thing that ChatGPT told you, or inversely. So this is, again, grounded in the sort of concepts of a coherent field, which sounds cool. Low energy, coherent; high energy, incoherent, right? So it's the structure, right? It's the optimal structure of the noise, the jitter, the stuff that sits in between to help us determine the factual information. I know it's like science fiction. And you can thank Roger for that. But so in low energy structure, everything agrees, safe to act. Contradiction in a high energy, contradiction, stop, escalate, or refuse. So now we have to benchmark this, but the idea here is not prediction. I'm 85% confident, zero contradictions found. Can be confidently wrong, knows when, knows what it doesn't know, and so on. Now, what's important here is I can embed this confidentiality system, this kind of confidence system, directly in the language model, and it's utilizing, again, the mathematical principles of all the math that we described earlier to describe it independently of the prediction or probability of the next word, sentence, paragraph. But the language model will basically reassemble it in a way that's meaningful. So then what that really means is we have complete lineage in terms of where and how the decision that was made to come to that conclusion actually happened. And so not only is it confident, I've got a deterministic replay of how that confidence actually came to be, and each step along the way that provided me the mechanism to be confident in that particular thing. Right now in a traditional language model, that's a black box. Nobody really quite understands what the output is, because that's a bunch of magic and a bunch of stuff happening that is just generating that result. I've got complete control over every single loop, every single decision, every single reasoning element, and I can cryptographically verify that and replay that using a seed. So we scroll this, we got LLM verification. So this is the LLM integration. We got the memory consistent tracking, confidence from coherence in different applications, anti-hallucination, trading throttles. This is particularly useful if you're doing stock trading, I would say. Drone safety, don't kill anyone. Zero trust security, am I being hacked? You see how it has a tendency to look in the future, scientific discovery, policy, machine self-awareness. Does the system know when it doesn't understand itself? What the heck does this do? That sounds crazy. We'll go a little deeper there. So the feature flags. It integrates directly with the Postgres governance system, Roove LLM. It can be distributed across multiple machines. It's got the attention integration, my NeuroGate, biologically inspired gating, so it's sparse spiking networks, MinCut for high-speed graph restructuring. Performance, it's always fast. Why prime radiant in Isaac? Here we go. This is the part. In Isaac Asimov's Foundation series, the prime radiant is a device that displays mathematical equations of psychohistory, allowing scientists to see how changes propagate through the complex system. Similarly, this prime radiant shows how consistency propagates or breaks down through the AI's knowledge graph. It doesn't predict the future. It shows you where the present is coherent and where it isn't. And that's the basis of any prediction. So here's the important part. And when you're looking at these systems and you're trying to determine what the future state is, you have to both understand the current state as well as the sort of ramifications of decisions you're making at any given point and what those will sort of collectively propagate and change. So this creates a mechanism. I've got the mechanism to sort of do broad simulations in the next several years or whatever, but I also need a kind of guidepost, a map that helps me navigate that future. What this does is provides the sort of pressure of reality, the complexities of chaos and entropy and decisions that are made, and then and can do real-time readjustment like a Google map. I turned left when I should have turned right. It refigures out the mechanism to get me to the destination. This destination is my probable future that I'm working towards. So if your probable future is, I want to be successful, I want to be a billionaire, I want to create a company that is the number one in my space, it can help you guide you through all the complexities of those decisions based on looking at all the things you never thought to look at.
Hey, Ruben, quick question. A general purpose transformer is focused on next token prediction, right? So it's predicting the future of what the next tokens might be. Is this are you basically saying this is a new type of transformer?
Oh, I've created dozens of new transformers over the last couple months. And the ability for transformers for me is the intersection of attention, and I can create min-cut style attention mechanisms and others. So your question, literally, you're reading my mind. So now that we have the basis of this kind of anti-pattern, the question is, can we apply it to a kind of transformer model? So let's ask, can we use this to create a novel, new transformer? You know what I mean? A novel, new, low latency transformer. Don't implement. I'm curious. We know what the answer is. Of course, as you point out, it's ideally suited for that. It allows us, it allows us to understand the things that are difficult to understand, which is perfect for a transformer, right?
Yeah,
And
exactly.
so why is it 5 to 10 years out? Building reliable self models that can be checked this way requires solving several hard problems. It's speculative, but the math would be the same. Just apply to our system's representation of itself rather than the external factors. It questions its own existence. It reasons about its own reasoning. It questions its integrity and says, is that integrity about to break? It can then reevaluate its own integrity in real time using MinCut and that algorithm. All right, I'm almost out of time. I gotta hop to a call here in a minute. But okay, so we have a coherence transformer. The core insight: most tokens don't need full attention. You use coherence energy to decide what computation to skip. That is the optimal thing for my edge-based chip. You're right. I don't need you to pay attention to everything. I just need you to pay attention to the things that are meaningful relating to the problem in which you're focused on. Birds. So the problem with standard transformers, input n token, standard, every token attends it has the same attention, right? So you brute force it, and that's why GPUs work so great, because you're basically doing everything. I don't want everything. I only want something. So in this architecture, you've got this idea of input, embed, coherence check, and then real-time routing. And I get different levels of attention. I can mix and match those attentions. So the token level routing, attention sparsity. So the sparsity is the idea of spiking. So kind of how your brain works, right? I'm not using all of my brain. I'm only using the parts that are need to do whatever it is I'm doing at any given point, which is much more efficient. Early exit via energy convergence. So I'm monitoring the energy. Now, that is really important as well. So now that I've been digging into the world of chips and whatnot, every joule counts. So this idea of correlation between energy spent and intelligence received becomes really, really important. I don't want to just blast through, again, GPU style sort of inference, asking every question and getting the probable answer. I only want the one answer and the minimal amount of effort, time, speed, energy, and other various levels of consumption to get that answer quickly. That's what this is doing. All right, now we have that. Update the ADR to include in our attention crate. Now we've got an attention crate.
I like you're talking about the every joule counts, Reuven. I think that's really important for the Agentic Foundation as one of our core principles, because we're really, if you look at OpenAI and Anthropic and Grok, they're sloppy. They're lazy, right? They just throw CPU, throw energy, throw everything at it, and we don't, right? One of our core principles is be efficient, be optimized. Every millijoule matters. Every CPU cycle matters. We're the opposite of those guys.
And we're 100% the opposite. We're if the current world, and nothing against Grok, the sort of accelerator company, but when you look at TPUs and GPUs and that kind of brute force approach to AI, it's lazy. It's lazy, man. They're basically saying, hey, let's try to solve the problem by answering all the questions possible. And they're not even trying to solve all the questions. They're basically saying, we're going to try to look at all the stuff we've sort of crammed into this multi-billion parameter model and then decipher what the most probable answer is. But that's stupid. It's not how information works.
I agree, man. And then NVIDIA will say, here's 1,000 GPUs. Just throw them at your problem. And write sloppy code and don't care about cycles, CPU cycles and memory and latency. Just be lazy.
Yeah, and you just described every Python developer on the planet, right? And that's why that's why there's a tendency for Python. It it's permissive. It kind of works even when it doesn't. You can write bad Python and somehow make it work. Rust is the opposite. It's really hard to write bad Rust because it's ultra optimized. And the
Well,
more
I
you
agree,
get,
man.
the
I'm a
better.
Rust. I love Rust, man. I love Rust.
Yeah.
I was inside an NVIDIA startup like 3 years ago, man, and I'm like, Rust is the future of AI coding, man. I'm telling you, dude, Rust is the future. And everybody was like, no, it's too complicated. No, man, it is the future.
Yeah. Well, I'm out of time and I got to jump on the next call here, guys. But tomorrow we're on the AI hacker space. We'll see what this does. We've invented several new things here today, by the way. I don't think anyone's created all.
I fixed my command line.
And so if you guys want to take a look, you'll see it in the in my slash what's the branch here? Just I'll publish it later this afternoon. It's the Coherence Engine branch on RooVector. If you want to take a sneak peek of what I've output, I've committed it all to that branch. I'm sure Colby, you'll take it and do some crazy thing.
I will. I fixed the status line thing too. By the way, that's what I was talking about.
All right,
while we were on here. It's like
I appreciate it. All right. Until next time, guys. Thanks everyone.
Thank you.
Thanks.
All right.